Hi folks, today I still talk about the VFD drivers, and the reference of the driver I have here in this board. This is a board from the box, TV box, or optical fiber box. The reference is the STFPC320. And this IC can drive directly the VFD tube, or in this case, like you can see, use the 7 segments display, and is working like the normal situation. The IC have the power up of the 3.3 volts, okay. And the funny of this IC, the internal real-time clock, the RTC, is like the internal RTC from this board, this tin board. This is a tin board from the DS8040, and you can find it because it's used with Arduino, okay. Have a battery to keep the timer, the configuration, and have a real-time clock, and the first 16 address or 16 bytes from this IC is like this IC also, okay. The configuration, the square wave clock you can send to the external is the same configuration. Here I have the implemented with 1 pulse by second, but you can go to until 32768, and is exactly the same configuration from this board or this IC, okay. If you expend time to work with this real-time clock, you find easy to work with this board also, okay. If you look at the board here, you can see I have implemented here the additional 5 buttons, okay, because the original board don't have these buttons here, but the circuit, the remaining circuit, is already implemented, okay. You only need to insert here the 5 buttons and they are ready to work, okay. The board have also 3 LEDs. These 3 LEDs is direct connected to the port of IC through these 3 transistors located here around the chip. The base time is this IC, and you have 1 independent LED here, which is set with the digit you can configure to make the separator here between these digits, like a clock, okay. You can use the score or the 2 points, or how you prefer, and this LED here is set like the digit, the middle digit to separate the clock. The pin out of the connector, the external connector of this board, have let me try find the documents. Let me see, is here. You can see here the connector, okay. And the first pin you see here is 3.3 volts. After you have V and D, this is the pin you need to connect through a resistor to the VCC, in this case 3.3 volts, and this pin is responsible to power up the LCD or the display and also the LEDs. Okay. After you have another GND, this 2 is not marked. After you have SDA, SCA, this is the bus to connect with the processor. This is not marked. You have the standby. The standby inform if the status of the STFPC320. In this case, I have added one LED to bright when it is in standby mode. After you have the IRQ to active the external square waves, okay, only to bring up the LED. This is not marked. After you have the ready pin, and this ready pin is necessary go to the VCC, in this case 3.3 volts, before 5 seconds after you power up the system. Okay, if you don't bring this pin to the 3.3 volts, the system go to sleep. I'm using this process, but you can use the pin from the processor to control it. Okay, in this case I connect to the VCC 3.3 volts and load to the resistor and expend some time to change the lever from this capacitor to the VCC. Okay, this is the mute. The mute is to avoid the sounds in the speakers. Okay, you can use to control the information of the speaker. Also, I can tell you which is the transistor responsible to drive with the 7 segments display. In this case is TE6, TE9, TE10, TE13, and here TE24. Okay, this 5 transistors is responsible to control or to drive the common pin of the display. And another thing is important is the reference and the pins you can read related with the keyboard. This board or this IC support 24 keys, in this case 2 times 12 or 2 times 12, and here you can see the hexadecimal value which is activated when you press the button. Okay, you start in SE1 and go to SE14 and is here 14, yes, 12, 13, 14. These signals you can read in the terminal of the Arduino or the console of the Arduino and check if it is implemented or not. Okay, to read your change of your display. I tell you, this is internal clock, and to adjust the time I need to make some lines of the code to adjust the clock. In this case, I have here a button to swap the normal display to the clock. Okay, if you see here, when I press this button, you see SS is not 55. Okay, I adapted it, and here you see 00 seconds. If I press the up button, you see the seconds go up or go down. 5. And after to adjust the next digit, I press the right button, and after press the upper button, okay? I don't have the protection to the read of the buttons. I don't implement the code to the protection, okay? By this reason, the buttons is pressed and change every seconds. After you can press the second button, in this case the third button, and you see the M 00 minutes, and you can adjust the decimal minutes for 5, and after press the button to right, 2, 4, 6, 8, and the 9, for example. And now the hours, this case is 13, I put here, for example, 23, okay? And after seconds, is necessary put here 43 seconds, for example. The minutes, 59 minutes, hour, 23 hours, and after you press here the set button, okay? And this is the time you adjust your clock, the real-time clock. After you skip the missing seconds, you will change to 0 hours, okay? It's very easy to use, and if you look to the code, you will see how easy to implement this process. Also, I have implemented the read of the infrareds. For example, if you see here the yellow right now, okay, each time I press the button 2, or if I press the button 4, for example, you see the red and the yellow, okay? Red, yellow, and yellow here. This driver have implemented internal the decoder to read the protocol of the communications with the RC5, Sony, Matsushita, NEC, have a lot of the decoders you can use because it's already implemented in the chip, okay? In this case, I only do a small part of the code to be able to read in the console of the Arduino, okay? I will try to show. It's here, is running, and if I press, for example, the button 2, you see the change of digit 4 or 6, and this change belongs to the protocol, okay? Every time you press the same button, you only change 1 bit. Now I press 1, now I press 3, and so on, okay? You see, if I press the same button, for example, in this case, I press the button 0, and you see the number 7 is permanent, but the 4 and the 6 is changed, okay? And this process is already implemented in the internal IC, okay? Also, I have a key. In this case, I think is the key 12. Yes, is the key 12 to read the time present in the chip. Okay, if I press here, you see here the time is present here. Okay. I will stop here, okay, and here, and now press the button. Okay. In this case, the time present is 4 minutes, and if you look here, you have the 43 seconds, 59 minutes, and 23 hours, because it's the setting I have sent it to the IC. Okay. This is a running mode of the read time, and after the show time to the console of the Arduino, and you can see the weekday, the hours is 2 minutes and 32 seconds, 34, and so on. And also you have the information present in the infrared port and the keys. In this case, the keys is 0. If I press, for example, the S1, you will see here the 1 present. And if I send the digit 9, for example, you will see the 47, and the change. I still press the button 8, sorry, is 8, not 9, and you see the 4 and 6 change every time. If I press another button, the code 2F37, 37, 47, and so on, each time you press the different button. Okay. The code have implemented a routine will run at the begin to test the VFD. You see now the count. You can see the gap between the second digit and the third. This gap time is because the third digit is implemented in the software to use the dash to separate the hours of minutes. After implemented the test, the clock running in normal mode, and the time is set at the begin is 23 hours 59 minutes and 45 seconds, I think, to be possible to skip so fast as possible to 0 hours. This green LED here blink with the cadence of 2 seconds, okay? Because here you can see here the 1 hertz it's coming from the square wave configuration of the internal clock, but here this green LED is blinking to the cadence of 2 by 2 seconds, okay?